Are we ready? Okay, here we go. I want you to write this. Properties of electric charges. I want you to make a table with 3 columns. And 3 rows. In the middle, I want you to write and I want you to write scalar description. Here, I want you to write interaction between 2 charges. And here I want you to write effect of a charge or charges at a point in space. And I want you to make the girl that we've always made twirling. So our handy dandy picture in one corner. And so this box with the girl, what should I label it? Field? In this case, what kind of field?
Electric.
Excellent. And I'm going to call this E. Then I want you to draw an arrow. And I want you to draw an arrow. And I want you to draw an arrow. And I want you to draw an arrow. So electric field is what we have. If we want to keep the electric field in my equation, but I want to talk about the interaction between 2 charges, what do I call that? That basically means is I'm bringing a charge in the vicinity of the electric field. What did I call that?
Force.
Excellent. So force will go here. Note, both force and electric field are vectors. Hence, this is the vector description. Now, the equation I gave you guys yesterday was the ED equation. V on this side. Yes, and also you remember it was fancy, V equals integration E dot dl, but I'm just trying to keep this simple. And what should I put on the right bottom corner?
Potential.
Very good. Potential, which is a scalar. So it goes in the scalar description. Now, what should I put against this arrow? Pick an arrow. Which one do you want to do? Let's go from electric field to force. What's the relationship?
F equals QE.
There we go. So how do I convert F to E or E to F? F equals QE. Very good. And what are the units for force? Newtons. So what should the electric field units be? Newtons per coulomb. What's the unit for potential? Volts. And what's the last thing that's left? Potential energy. Yeah, excellent work. Something has to be done, right? So force does what? It does work. Or when you do work on something to lift it up, it gains potential. Very good. You could also write work in there as well, but I'm just going to keep it very simple. Like very few words are going to go in this table. So it'll be like a hint, just pick it up and you'll know exactly how to go from one place to another. And what is potential energy? U. What should I put here? U equals QV. And then there's only one other arrow that I might be missing is the relationship between these two things. Do we remember what that relationship was? U equals QED. The units of potential energy are joules. Then that means units for potential are joules per coulomb. That's all I want you to put in this table. Very simple, very straightforward. Glance at it once, you should know the entire thing. Good?